Okay, I'm gonna do the next set of questions, which also coincidentally involve exponents. So the first thing is the third root of 125 r to the fourth s to the ninth t to the seventh. Okay, so it's a matter in this question. It's just in questions like these, it's just a matter of how much can hop out of that root sign thingy. So we already know that 125 is 5 cubed because we've memorized all of the cube things and we've done all of that, memorizing the lists of all of the numbers cubed and all the numbers to the fourth. So 125 is 5 cubed, so that can hop out. The other trick that we want to use when trying to bring all of the as much as we can out in these problems is the breaking up the variables. And this is what I mean by that. I mean that r to the fourth is equal to it. Well, firstly, you can't bring r to the fourth. You can't bring all of it outside because 4 isn't divisible by 3. You know, the third root of r to the fourth doesn't come out as a number that can be rational, that can sit outside of this thing. But what you can do is, because r to the fourth is r times r times r times r, in that is r to the third. So r to the third can be turned into a rational number on the outside. So you get, I'm going to just convert this, r to the third times r. So that's how you just sort of divvy it up, and you divide it up until you get a number that's divisible by the number out here. So you can bring it as a rational number on the outside. So that s to the ninth can come outside because 9 is divisible by 3, and then t to the seventh can turn into t to the sixth times t to the first, which is just t. And so 6 is divided by 3, so that can come as an irrational number out on the outside. So you get 5 times r coming out, the r to the third coming out, this is r, times s to the ninth coming out of being irrational, s to the third, and then t to the sixth going out as t squared. And then whatever's left over is just left behind, the cube root of rt. And so that's it. That's how you do that one. Let's see. Next, for this one, this one's pretty easy. You got x to the 2/3 times x to the 1/4. So when you're multiplying with exponents that have the same base, you just add the exponents together. So it's really just x to the 2/3 plus 1/4, like that, if you can see that. So it's the denominator. 2/3, let's see, 2/3 is 8/12, and to give 1/4 that common denominator, we could say 1/4 is 3/12. And then we add these together, 11/12. So it's x to the 2/3 plus 1/4, x to the 11/12. That's the answer here. I was just gonna box in the answer of this place. Yeah. So for the first one, you have to figure out what can come out of the irrational root sign, and then bring it out, and then leave whatever can't come out behind. And then for this, for things like these, when you're adding fractional exponents together, you just figure out how they can have a common denominator and do that. It's like addition from earlier, like from middle school, except you're doing it in a more complicated context. Yeah. So next, we have the square root of 3 over x to the 4th to the 1/3. So I think I tackled something similar to this in the last video, but all we have to do here is that, well, the exponents of the x's are sort of like in plain sight. They're just hidden under all of this formal stuff. So the square root of x to the 3rd is the same as x to the 3rd to the 1/2. And meanwhile, on the bottom, x to the 4th to the 1/3 is equal to x to the 4 over 3. If we can simplify it even further, we get x to the 3 over 2 over x to the 4. X to the 3 over 2 over x to the 4 over 3. And then, because x to the 4 over 3 is on the bottom, we can flip it on top and make the exponent negative. So we can say that's x to the 3 over 2 times x to the negative 4 over 3. And now we can see this looks pretty similar to the last problem, except it's subtraction instead of addition. So it's x to the 3 over 2 minus 4 over 3. So we just have to find a common denominator for the two fractions like we did in the last problem. So it's x to the, let's see, like not 9 over 6 minus 8 over 6. And then that comes to x to the 1/6. And that's the answer. So the summary for this problem was that it was all hidden behind all of these like notations and formalities, and we just had to bring it out to the basic exponents and how they looked, and then it turned into an addition problem. So that's how you did that. So the video's already way too long. Okay, that's all for now.